Hi everyone, I am Dr. Zahid Professor, Department of Electronics and Communication Engineering, LNST Bhopal, and the topic of today's presentation is Z transform and its properties. So basically, as we all know, Z transform is a digital transformation technique used for discrete signals. Previously, we have studied different analog transformation techniques like Laplace transform, Fourier transform, and those transforms are good for continuous signals, but for discrete signals, we need digital transformation techniques, discrete Fourier transforms, fast Fourier transform. So, in today's topic, we'll discuss about the basic Z transform and its properties. So, students, why we have chosen Z transform? As we have already discussed, it is useful for digital transformation of discrete signals, and many signals like un, sine, and omega do not have a DTFT. For those signals, we need to have Z transform. Z transform has many advantages like Fourier transform. Here the signal yn equal to xn into hn can be represented as output yz is equal to input xz into hz. Properties of systems here can be easily studied and characterized in Z domain, unlike Fourier transform and Laplace transform where we rely on S domain. So we come to the basic definition of Z transform. The Z transform of a basic discrete time signal, which is denoted here by xn, is defined as xz equal to summation n equal to minus infinity to infinity xn set to the power of minus n. In simple notation, we can also write xn with an arrow upper. Above that, we can write z xn transforms into xz. Now comes the most important thing in Z transform is region of convergence, that is ROC. ROC is that region where xz attains the finite value. This is the ROC and the Z plane, where in x-axis the real part and then the y-axis the imaginary of Z is there. So a complete plane can be written as Z equal to real of Z plus j into imaginary of Z, which is also equal to r e power j omega. And a unit circle has been plotted for the ROC here. If we talk about the basic properties of ROC for right-handed and left-handed sequence, we'll discuss further what are these sequences, right-handed and left-handed sequence. You can see here the Z transform with a ROC will be the exterior of the circle when the ROC Z is greater than alpha. When the ROC Z is greater than something, then the ROC will be the exterior of the circle, and this will be the right-sided sequence. For a left-sided sequence, the ROC will always be the interior of a circle, and it can be written as ROC mod of Z is less than beta or alpha, whatever be the value. Now, as we have said the right-sided and left-sided sequence, we'll discuss here about the right-sided exponential sequence. Most basic discrete signal, that is xn equal to a power nun. We are taking the Z transform of it xz equal to summation n equal to minus infinity to infinity a power n un z to the power of minus n. In place of xn, we have substituted the value a power n un, and it is equal to n equal to 0 to infinity. Why? The unit step function is having the limit 0 to infinity. It is applicable between 0 to infinity. So summation n equal to 0 to infinity az inverse whole power n. Finally, the z transform of this will be xz equal to 1 upon 1 minus az inverse, or we can write z upon z minus a. For calculating the ROC, we'll substitute mod of az inverse less than 1, and we'll get the value mod of z greater than a. That is the ROC for this function, and that is z greater than a is nothing but the exterior of the circle, which we have discussed in the previous slide. Now if you see here, if the value of a is less than 1, then you will see here it will be inside the unit circle. This is the real axis, imaginary axis, this is the z plane, and the ROC is z greater than a, so this is outside this circle. This region will be the ROC for xn equal to a power n un. Okay. Now, as we have said previously, we are now discussing about the left-sided exponential function. You can see here xn is equal to minus a power n u of minus n minus 1. This is a clear example of left-sided sequence. If we take the z transform of it, xz equal to n equal to minus infinity to infinity minus a power n u of minus n minus 1 z to the power of minus 1. This complete thing is xn. Now, if we substitute this inside the summation equation, you will see the limit changes from n equal to minus infinity to minus 1. A power n z to the power of minus n, and the minus n as it is. In the next step, minus sign as it is, and the limits changes its sign. From minus infinity to minus 1, it has been changed from 1 to infinity. Now what will happen? A power n becomes a power minus n, z of power minus n becomes z to the power of n. And then we can solve it, and we'll get the value 1 upon 1 minus n z upon z minus a. Okay. Now, here in this case, if we substitute the value a inverse z less than 1, this is the ROC, and it comes out to be z less than a. That means the interior of the circle. Z less than a, it is the interior of the circle. This is the shaded portion. Now this shaded portion will be the ROC for left-sided exponential function minus a power n u of minus n minus 1. So this is the difference between the right-sided and the left-sided equation. There we have seen the ROC is the exterior of the circle. Here ROC is interior of the circle. Another example we can see here, it is a two-sided function, and function is xn equal to minus 1 by 3 power n u of n minus 1 by 2 power n u of minus n minus 1. As we have solved it in the previous two slides, these type of questions, clearly we can discuss here about the ROC. The transform is not a big deal. We can directly solve it. 1 upon 1 plus 3 z inverse, and here 1 upon 1 minus half of z inverse, and then we can solve it like this. But if we talk about the RAC, here ROC is z greater than 1 by 3, that is the exterior of the circle, and here the interior of the circle z less than half. The combined ROC is a big factor here, and that will be equal to 1 by 3 less than mod of z less than half. So ROC, what it says, here the ROC will be this shaded portion, or we can say the ring of the z plane, that is the real and imaginary z plane. ROC is nothing but the ring portion. ठीक है. So next slide. Now we are discussing about the basic properties of Z transform. First property is linearity property. Linearity is nothing but a combination of two or three linear functions. So if the Z transform of Xn is Xz, so and Xn is Xz and Yn is Yz, then the linearity function says Yn Wn equal to A of Xn plus B of Yn. The Z transform will be Wz equal to A of Xz plus B of Yz. Now the big factor here, what will be the ROC of Wz? What will be the ROC of Wz? That we have discussed in the previous slides. That is the best example of linearity property, where we can say the ROC includes the intersection of X and Y. ROC includes the intersection of X and Y, and there we have seen how a ring structure has been formed in the Z plane. The next property is shifting property. It says if Xn has a Z transform of Xz, then X of n minus n0, the Z transform will be Z to the power of minus n0 into Xz. Another property is time reversal. It says if Xn has a Z transform of Xz, then X of minus n will be having a Z transform of X of Z inverse. Similarly, we can discuss in the coming sections, if Un is having a Z transform of 1 upon 1 minus Z inverse, then U of minus n will be having a Z transform of 1 upon 1 minus Z. Now the next property is multiplication by an exponent, the scaling. If a sequence xn is multiplied by alpha to the power of n, then the Z transform is nothing but x of A inverse Z. Another property is convolution theorem. We have been studying convolution theorem right from the Fourier transform. Yn equal to xn into hn, having the Z transform yz equal to xz into hz. Now comes the derivative property. Derivative property, if xz is a Z transform of xn, then n of xn is having a Z transform of minus z d by dz of xz. That is the derivative property. Initial value theorem. If we talk about the initial value theorem, if xz is having the Z transform of xn and xn is equal to 0 for n less than 0, then what will be the initial value? x0 may be found from xz as limit z tends to infinity xz. Now these are the basic common Z transform pairs, and we can discuss in further classes also in further presentation. The first one is the del n. It is having a Z transform of 1, and the region of convergence says all the values of Z. Another one is alpha power n un, having the Z transform 1 upon 1 minus alpha Z inverse. ROC Z greater than alpha, left-sided sequence, the right-sided sequence we have already discussed. The fourth one is an example of derivative functions. And then at the last, cos n omega 0 un and sin n omega naught un. We can solve it by using the exponential function, and it is having the value 1 minus cos omega z inverse upon 1 minus 2 cos omega z inverse plus z to the power of minus 2. And it is having the ROC z greater than 1. Sin n omega n un is having the function sin omega 0 z inverse 1 upon 1 minus 2 cos omega z inverse plus z to the power of minus 2. In the next presentation, we'll solve these problems in more detail. Now that is a quick review of the different properties which we have seen today. The first one is linearity property and the region of convergence, the intersection of those values. Second one is the shifting property. Then comes the time reversal property. X of minus n is having the z transform of x of z inverse. Exponential function, scaling function, x of a inverse z, the convolution xz into yz, conjugate functions, and the last one is a derivative function, that is minus zt by dz of xz. So these are the most basic properties which has been used in Z transform. So students, today we have discussed the basic Z transform and the basic properties regarding the Z transform. If you have any queries regarding this question, we can discuss in lot more detail, and we can discuss it in a very detailed format in the coming classes. So thank you everyone.